Right, okay guys, this week we're going to look at bearings questions with trig triangles. Now, this is really what we've been building up to. These are probably the most difficult questions you would face to do with sine rule and cosine rule and all that kind of stuff. And they generally will come right at the end of a paper, so they do kind of fill that gap of trying to sort out the people who get a really good A from a kind of standard A or the people who get an A from a B. There are a few ways round this though, in terms of if you really struggle with this, and I'll talk you through it as we go. I'm basically going to take you through 7 or 8, I think it is, past paper questions. Now, this is going to be long, okay? 7 past paper questions just I've gone for. This is going to be really long. I've downloaded for you and put it up the sheet that this comes from. I think there is an 8th question that I've not included. Okay, in case you want to work through them again and try them yourself and then refer back to the video. This is something that's going to be quite back and forward, I think, this week. You're going to need a wee bit of support with it. But hopefully we'll get there with it. But don't worry if we don't, okay? There'll be a bit of revision time next week that we can look at it. And also we can cover it once we're back in class, where maybe it'll be easier. But you know you can access help from me anytime. Okay. Now, there's a couple of things we need to remember first of all. And we've not talked about bearings for a while, okay, if ever. So a few things that we need to remember. A bearing is always measured from north. So we always have to have a north line. It's always measured in a clockwise direction, and it's always given 3 figures. So if you were looking at the bearing of northeast, which is 45 degrees, you would write 045 degrees. Okay, so there's 3 kind of starting points. We'll talk a little bit more about the language and stuff as we go through it, as we see it pop up into questions. But don't expect this all to click straight away, guys, okay, because there's a lot going on in these questions. Right, so question number 1. A ferry and a trawler receive a request for help from a stranded yacht. On the diagram, the points F, T and Y show the position of the ferry, the trawler and the yacht respectively. So we've got our ferry, our trawler and our yacht. Now, FY is 7.2 kilometres, TY is 5.6 kilometres, FT is 10.3 kilometres, and F is on a bearing of 240 degrees from T. So there's the language that we need to think about. This F is on a bearing of 240 from T means that if we are standing at T, the angle that the line to F is at is 240 degrees from north, okay? So F from T means you're standing at T and you're trying to get to F. Now, we are asked to calculate the bearing of the yacht from the trawler, okay? So from the trawler means you're standing at the trawler, okay, which is over here, where I've got that red dot that I've now covered with a black dot. So we're standing at the trawler and we want the bearing of the yacht from the trawler. Okay, so the bearing of the yacht from the trawler this was the bearing of the ferry from the trawler. So the bearing of the yacht from the trawler, we need to keep going and get that final little bit. So the first thing I notice is the bearing of the yacht from the trawler is going to be more than 240 degrees. It's going to be 240 degrees plus that angle in there. So let's call that X. Okay, and that's the angle that we're being asked to find. Now, hopefully you notice you've got all 3 sides. All 3 sides means we use cosine rule. Okay, we've got an angle. We've not got an angle, we're trying to find an angle, and we've got all 3 sides, so it's going to be cosine rule. So for argument's sake, let's turn this into A, because it's cos A. Let's turn this into B, and that therefore means that Y becomes C, so we've got little a, little b, and little c. Now, cosine rule. Let's get this written down. Cos A equals b squared plus c squared minus a squared over 2bc. So we've got 5.6 squared plus 10.3 squared minus 7.2 squared over 2 times 5.6 times 10.3. So we work that out first of all, grabbing the calculator, using your fraction button if you like doing it that way, or whatever way you have decided you are most comfortable with doing this, then you make sure you're doing that. Making sure that you've typed it in correctly as well, remember guys, it's always worth double checking your screen. If you don't have a scientific calculator at home, there are a few good apps you can use, so let me know if you're struggling and I can show you those apps. Okay, but I get 0.742. Now remember, that is cos A. That is not the angle. Okay, so to get A, or X I guess, we're doing inverse cosine of that 0.742. So shift cos on the calculator, and that brings you up 42.1 degrees, 42.088. Therefore the bearing, okay, would be 240 plus that 42.1, which is 282.1 degrees. But we wouldn't get the mark for that, guys. Remember right at the start I said that we give 3 numbers when we do a bearing. Okay, so we need to round this to just be 282. We don't talk about point whatever degrees. So the answer to that one would be 282. Now that one's not too bad in terms of a bearing question. The only really tricky part is that maybe yellow bit that's highlighted, just understanding the concept of what the question's actually asking us in terms of the bearing. Okay, getting that language. Let's look at the next one. Question 2. In the diagram below, D, E and F represents the positions of Dunbridge, Earlsford and Fairtown respectively. Dunbridge is 50 kilometres west of Earlsford. From Dunbridge, the bearing of Fairtown is 126. And from Earlsford, the bearing of Fairtown is 230. So that's kind of all detailed on there, apart from the fact they're kind of missing off the obvious, that if Dunbridge is west of Earlsford, then that has to be a right angle in there, because the bearing is 270, so what's left is 90. Oh, sorry guys. Okay. And then if that's a right angle, this is obviously going to be a right angle here as well. And so sometimes these little right angles will pop up if it's talking about east and west. You also need to know your other bearings like northeast, northwest and so on. So that might be something we need to do a bit of revision on. Now, what's the question actually asking us? Let's have a look. Calculate the distance between Dunbridge and Fairtown. So we are trying to work out this distance here, which will be little e if we look at the triangle. And we've got little f, and then we've got some stuff to do with angles, but we've not got a huge amount. Okay, so let's have a think about this first of all. Well, we want the angles inside the triangle, and at the moment we've got these bearings that are kind of hanging about around the outside of the triangle, giving us bits of information, so we're going to have to use them to help. Now, let's focus on this area around this point D first of all, this Dunbridge. We know that from north, the bearing of Fairtown from Dunbridge is 126, okay, but we also know that the bearing of Earlsford from Dunbridge is 90 because it's due east of it. So 126, take away that 90, would leave us with 36. So that tells me, guys, that this angle in here is 36 degrees. Now that's far more useful to have, the angle inside the actual triangle that we're focusing on. The other thing to bear in mind is we were told in the question that Dunbridge is west of Earlsford, which means that from here all the way round to there is 270 degrees, because that's what bearing of west is, remember, okay? And we know that from here to here is 230 degrees, okay, the bearing of Fairtown from Earlsford. So again, what's left? 230 to 270. This angle in here is 40 degrees. Okay, now I always say to you, if you can get two angles, then you should always work out the third one as well, because it might come in handy, and it is going to here. If we add these two together, we get 76. So what's left is 104. Okay, So that angle there is 104 degrees. Now I'm going to redraw my triangle now. Okay, with the information that I've got, try and get rid of some of the other stuff. This is 15 kilometres. This is 104 degrees, so that's good. We've got a pair. We're trying to get that side E, and we know the angle across from it as well, that 40 degrees. So that's all the information we need, guys. If you think about the work we did last week, we've got an angle and the side across from it, and we've got an angle, and we're trying to get the side across from it. So we can use sine rule here, okay? So if we use sine rule, it will be E over sine E, or sine 40, equals 15 over sine 104. And from there, E is going to be 15 times sine 40 over sine 104. And at that point, we're grabbing the calculator, making sure we type it in correctly, making sure we close any brackets we need to, and so on and so forth. If we've got to this stage and we've been doing the work as I've been asking you to, then that shouldn't be a problem, because you should be keeping up with all that, or letting me know that you've not got there. And we get 9.3698 and so on. So I would say that the distance between Dunbridge and Fairtown is 9.94, and it was in kilometres. Okay, that was a wee bit of a trickier one. There was more information required to do with the bearings and working them out with angles. If you were ever doing that question and you thought, do you know what? I know I need to get this angle here, okay, and therefore what do I need to do for that? If you were really struggling to get the angle, but you knew the rest of the question was going to be sine rule, make something sensible up. Because this question would be worth 4 marks. If you make up an angle for that 104 that looks sensible, so pick something that's more than 90, okay, and use it to do the rest of the question as a sine rule question, okay, then you would get probably 3 out of 4. Okay, so with all of these bearings questions, I'm going to show you where it would be a good idea to invent something, to make something up. Okay, now, we're already 12 minutes in, guys. What I'm going to do is I'm going to do one more question, and then I'm going to stop, okay, and then I'll make up a second video, okay, so that you can kind of have a bit of a breather. You can watch one if you're not coming to the live lesson and you're just watching the video, or you're catching up. You can watch one, maybe try a couple of questions from the work I've set you, and then maybe watch the other one. But you might just want to watch the whole thing, but it'll give you options. Okay, question 3. This is quite a common question. Again, this is one that we've actually kind of looked at already. This is not going to be one of the trickier ones you see. Okay, but it is quite a good one to have a look at. In the diagram below, P, Q and R represent the positions of Portlea, Queenstown and Rushton respectively. Portlea is 25 kilometres due south of Queenstown. So we've got the idea that from here to here is 180 degrees because it's south, okay? From Portlea, the bearing of Rushton is 72 degrees. So what we've got is that this bit here is 72 degrees, okay? And then what we're also told, but is not marked on our diagram, notice, is from Queenstown, the bearing of Rushton is 128 degrees. Now, the reason it's not marked on the diagram is they're looking to check that you understand what that sentence means. Now, it says from Queenstown, which means we start at Queenstown, the bearing of Rushton, so starting at north, going clockwise, the bearing of Rushton, to get to Rushton, we're on that line, and that's 128 degrees. Now, as soon as we mark that on, you can probably finish this question, guys. You're asked to find the distance between Portlea and Rushton, so that's that distance there. Okay, what are we going to have to do? Well, we know that Portlea was due south of Queenstown, so that this line here is 180 degrees. We've got the 128. If we take that away, that gives us 52. So this angle in here is 52 degrees. So again, we've got the angle and the side opposite it. We've got a side. Oh, we don't have the angle opposite it, but we can't be using cosine rule. Okay, because for cosine rule, all the information needs to be around a point. We don't have that either. For cosine rule, to get a side, we need two sides. We've only got one. Okay, but what we can do, remember, is we can work out the missing angle in that triangle. We've got 72 and we've got 52, so we add them together, we get 124. Take that away from 180. This angle here is 56 degrees in there. Okay, and remember, if you're struggling but you know you need that angle, make it up. Make up something sensible. It's obviously less than 90. Okay, and then it means you can do the rest of the question. So this angle here is 56 degrees. This side here is 25 kilometres. Okay, then this angle here is 52 degrees. And this is the side we're trying to work out x. Okay, so that means that x over sine 52 equals 25 over sine 56. Okay, so x is 25 times sine 32 over sine 56. And we'll go from there, type that straight in, 25 times sine 32 over sine 56, and I get 15.9799. Okay, and let's say that's just going to be 16.0 kilometres. Okay, it's very, very close to 16 kilometres. And so that would be our answer. That is the distance between Portlee and Rushden, 16 kilometres. Okay, so as I said, guys, I'm going to stop there. You might want to try a few questions and then come back, or you might want to watch the next video straight away.